my channel. In this video we are going to learn about the digital signals. What is meant by digital signal and what are the different types of transmissions in the digital signals and some parameters of the digital signals. Okay. So in the previous video we have seen how the analog signal will be transmitted. So normally the data will be stored in a digital format and system will transmit it through the transmission medium in an analog format, right? But so we can also transmit the signals in the digital format. Okay, so that is about the digital signals. For example, if 1 can be encoded into a positive voltage and 0 can be considered as a zero voltage. So 1 means high and 0 means low. Okay, so a digital signal can have more than 2 levels. Okay, so if you want to send more amount of data through a digital signal, then it will contain more amount of levels in the digital signals. So here we have two digital signals, one with the 2 signal levels and the other with the 4 signal levels. Okay, so here first we will consider about the one with the 2 levels. Okay, so in the level, this is the level 1 and level 2. So here, so we are transmitting the data at 8 bits per second rate. So here the bit rate is 8 bits per second. Okay, so here we are having level 1 and level 2, and 1 represents the positive voltage and 0 represents the zero voltage. So here the data is transmitted through the transmission medium with the 2 levels, that is level 1 and 2. And in this next diagram, so we are having the 4 levels to transmit the digital signal, that is level 1, level 2, level 3 and level 4. Since we are having the 4 levels to transmit the data, so we are having here the bitrate speed is 16 bits per second. That means that 1 second 16 bits are transmitted through the transmission medium. So we send in the first diagram, so we are sending only 1 bit, right? So we send 1 bit per level. Okay, and similarly in the second diagram we are sending 2 bits per level. Okay, so in general if a signal has L number of levels, then each level needs log L base 2 number of bits. Okay, so if it needs if it is having L number of bits, then it requires log L base 2 number of bits. So here we are using 2 levels, right? So in the 2 levels, so at a particular level, so we are setting 1 bit for a particular level, and here for the 4 levels, for each level we are sending 2 bits, right? So suppose if we are having n number of levels, then L number of levels, then we will send log L base 2 number of bits at each level. So now let us see a small problem regarding the digital signals. A digital signal has 8 levels. So how many bits needed per level? So in the previous diagram we see, so we have 4 levels, right? So now we are taking a digital signal with 8 number of levels. So that means, so it will be having 8 number of levels. So 1, 2, 3, 4 and 5 to 8. So 8 number of levels will be there, and so we have to know at each level, so what are the number of bits needed. So for each level, what are the number of bits needed, right? So we know that we are having a formula log L base 2. So here, so we are having the levels, number of levels is 8 log L, that is 8 base 2. So 8 means 2 cube, right? So 2 cube. 2. So now, so the number of bits needed to transmit per level is 3, right? So number of bits per level is log n base 2. So n means number of levels. So 8 base 2 is 3. So each signal represents 3 bits. So now the next parameter of the digital signal is bit rate. So we are transmitting a digital signal through the transmission medium. So we need to know, so how many bits are transmitted per second, right? So that is called as a bit rate. So number of bits sent per second is called as a bit rate. So most digital signals are non-periodic, and thus period and frequency are not appropriate in the digital signals. So here we are using the bit rate instead of frequency in the analog signals. So we are using the frequency in the analog signals. Similarly, we are using the bit rate in the digital signals. Okay. So bit rate means number of bits transmitted per second. So we are measuring it as the bits per second, BPS. So assume we need to download text document at a rate of 100 pages per minute. So what is required here? So what is the required bit rate of the channel? Okay. So here we are considering we need to download a text document from the internet. So with 100 pages per minute. Okay. So with a data rate of 100 pages per minute. So we are considering a text document, right? So in that document we are having the number of characters and lines. So we are having the line, and each line will be having some characters. So suppose normally a document will consist of 24 lines, and randomly it may consist maximum of at least of 80 characters. So we are considering all these things. So 24 into 80 into, so what are the number of pages we are downloading? 100 pages. So each page is having 24 lines into 80 characters. Okay, so 100 pages we are going to multiply it with the 100 into 24 into 80. Okay, here we are going to, here we are assuming the each character requires 8 bits. So that's why we are multiplying it with the 8. So 100 into 24 into 80 into 8 equals to 15,036, 1536000 bits per second. So we will simply write it as a 1.536 megabits per second. Okay. So next one is the bit length. So bit length means it is nothing but the distance one bit occupies on the transmission medium. So in the digital signal we are transmitting the digital bits of data, right? So the bit length means, so what is the distance one bit occupies on the transmission medium. So simply we are calculating the length here. Okay, so length of the bit, so that means the distance occupied by one bit on the transmission medium, and it is similar to the wavelength in the analog signals. Okay, so wavelength means, so if you want to know more about the wavelength, you can watch my previous video of the analog signal. Okay, so it is similar to the wavelength for an analog signal. The distance one cycle occupies on the transmission medium in a analog signal is called as the wavelength. Okay, similarly here the bit length is the distance one bit occupies on the transmission medium. So here in the bit length means it occupies one bit, the distance one bit occupies on the transmission medium. Similarly for wavelength, the distance one cycle occupies by the on the transmission medium is called as the wavelength. Okay, so bit length equals to propagation speed into bit duration. Okay, so next we will see the transmission of the digital signals. So there are two types of transmission of digital signals, that is baseband transmission and broadband transmission. So in the case of the baseband transmission, it sends a digital signal over a channel without changing the digital to analog. So normally if you want to transfer the data, so we need to convert the analog into, the digital data into analog signals. But here we are not converting it into analog signals. Instead we are sending the digital signal over the channel without converting digital to analog. Right. So normally the data will be stored in the format of bits in the system. So we are directly instead of converting, we are directly transmitting it through the transmission medium in the format of digital signals. A digital signal is a composite analog signal with infinite bandwidth. So we know that bandwidth is nothing but the difference between the highest and the least frequency. But digital signal means it is a composite analog signal with infinite bandwidth. If you are having finite means you can perform the difference between the highest and the least frequency. But here it is a infinite bandwidth. And baseband requires low pass channel, a channel bandwidth that starts from 0. The low pass channel means the channel bandwidth that starts from 0 is called as a low pass channel. So here from sender to receiver, the digital signal is transmitted to the transmission medium. So this is the low pass channel that starts from the 0 with a wide bandwidth, and this is the low pass channel with a narrow bandwidth that starts from the 0. So next one is the broadband transmission. So here we are using the modulation concept, whereas in the baseband transmission we are not using any modulation here, because in the case of the broadband transmission we are changing the digital signal to an analog signal for transmission. But in the baseband we are not converting it, right? We are directly transmitting the digital signal. Instead of converting digital to analog, we are directly transmitting the digital signal. But here we are converting the digital signal to an analog signal for the transmission purpose. So it uses a band pass channel that with a bandwidth that does not start from 0. So here the band pass channel is starting, we are using this band pass channel that doesn't start with the 0. So we are having this F1 and frequency 1 and frequency 2, which is not starting from 0. So we know that if you are having an internet connection, then you will be definitely having a modem. So modem is nothing but modulation and demodulation. Okay, so the term modem means modulation and demodulation. So why do we need the modulation and demodulation? So here if you are considering two systems, so which is connected to a internet. Suppose these two are connected to a internet here. Okay, so here the system will be of the digital format and the internet works on the analog format. So we need to convert the digital signal into analog signals, right? So digital signal into analog signal. So for this purpose we are using a modem, right? So here we are using a modem for each system. So here there will be a modem will be there. So we are converting the digital to analog signal and transmitting it to the internet. Then again, so while receiving the data from the sender, so it is again converting the analog to digital. So that's why we need a modulator and demodulator. So it will convert digital to analog and analog to digital. So that's why we're using this modulation and demodulation process in the broadband connections. Okay, so this is about the digital signals. Thanks for watching my video. Please do like, share and subscribe to my channel. Thank you.